Welcome to GCP Online Meetup number 14. Can we stop ransomware attacks? My name is Jonathan Cham, and I am joined here today by Alan Poole. We've had a lot of customers asking about this ransomware lately, and it's been an issue, right? It's a billion-dollar industry, tremendous financial impact, and many institutions that have been affected, including health, finance, infrastructure, government. And most recently, with the WannaCry ransomware, we had about 300K plus affected in over 150 countries by this ransomware. And at least for me, I don't like it at all. So today we are going to talk about ransomware. We're going to talk about what cloud vendors do about it and how you can help prevent ransomware on your end. I have today, join with me, Alan. Alan, are you there?
I'm here. Thanks for having me.
Hey, yeah, great. Thank you. And so, Alan, can you tell us a little bit about yourself, your background, and why are you interested in ransomware?
Hi. So I'm on the customer engineering team. I am a security specialist. I spend all of my time talking with customers of Google Cloud about security and compliance regulations and general kind of web security. I started on the Google Maps team back in 2011. So my background is in software architecture.
Great. That's great. And I know that you've been working with a lot of customers around our security posture here at Google Cloud. And maybe later we can talk about what typical customers are asking about security when it comes to going to the cloud. But I guess in just 2 minutes, can you describe what WannaCry was? Why did it get so much attention? And what is the impact of something like WannaCry?
Yeah, so WannaCry, which happened in early May of 2017, was a flavor of ransomware. So ransomware is a malicious piece of software or code that gets put on someone's machine, and in exchange for some type of currency, they're holding your system hostage. And in the case of WannaCry, it affected a known vulnerability in the Windows operating system, and it, like you said, it hit 300,000-ish devices across consumers, professionals, and governments around the world, and encrypted their actual device in exchange for Bitcoin. So this is not something new to enterprise organizations. It has been a security concern even over the last couple of years, but obviously, WannaCry had a significant, amount of news, and a lot of our IT administrators around the world are spending their time with their team, with their board of directors, trying to build a plan to react to ransomware in the future.
Yeah, and it seems like Bitcoin is kind of the preferred method for these type of payments, and I'm guessing it's because it's hard to trace back to kind of the original person, right?
It is, but there's an interesting counter to that. Traditional IT organizations don't know how to use Bitcoin or don't have wallets set up. So there's actually like the counter to using Bitcoin as being anonymous was that people had trouble paying. So it actually slowed down the ransomware attack in the case of WannaCry.
Yeah, and I'm guessing in general, our advice would be to not pay this ransomware just because I think it fuels this ransomware economy. And I mean, for me, it's like, even if I pay, I don't know if I'm actually going to get my data back, right?
Yeah, we typically don't advise on, what the best approach is. It really depends on what is being held ransom, right? It could be a movie, it could be your computer, it could be some, personal pictures that are really valuable to you. So yeah, every company needs to have a ransomware response policy, and needs to be ready to act. And that's just like any other vulnerability. There needs to be a kind of plan put together.
Right. Cool. So yeah, let's talk about kind of the statistics here.
Yeah, so let's talk a little bit about what is kind of happening. So let's go to what Google believes is kind of wrong with the ecosystem today. We really believe that traditional devices like desktops and servers and laptops are kind of built on a broken paradigm. They're really hard to update. They're really hard to kind of patch and upgrade hardware. They're IT administrators are spending their time updating virus detection definitions and backing them up. So especially as you bring on mobile devices and Internet of Things devices to the mix, traditional IT administrators are getting overwhelmed, and it's very hard to respond to a ransomware attack in these cases.
Yep.
So in the case of Google, we've learned quite a lot from our own workforce and our applications, and scale of these applications into the billions of users. Security is a big aspect of each one of these. Security needs to be built in, and needs to scale with the number of users that we have. And of course, our workforce is increasing, which means we're having to adapt our security posture to protect our own employees. Our product portfolio expands into new types of products, and the threat landscape is constantly evolving. So our security posture has to adapt to these.
And this is a pretty amazing statistic, right? 1 billion daily users, and I think like 2 billion on Android. Why does that make, the platforms more secure? Is it just by the nature of having to encounter so many different types of users and types of traffic and types of data?
Yeah, so when we're thinking about security in each one of these applications, it really comes down to these kind of 3 lessons that we've learned. Security needs to be built in to every one of the layers of technology that we have deployed. It needs to be built into hardware, to securely booting up these devices and servers. Needs to be running in an operating system that's very secure, all the way up to usage patterns of the applications. It needs to be default, and it needs to be easy for users, whether those users are consumers of an application or your own workforce. If security is thought of as red tape, people will circumvent them or refuse to update their system. So we've learned a lot by having these very large applications in the world and how to protect them. And we have security experts at every one of these layers, designing systems to thwart enemies and protect our workforce, our users, and our applications. The second piece of that is we see a transition from on-premise data centers to the cloud. And one of Google's strong suits is this serverless no ops environment, where Google manages the patching and maintenance of these systems for customers. And that allows traditional IT administrators to focus on more business value, actually doing the job that they're designed to do, and kind of pushing the tedious job of securing the operating system, for example, to Google in this case.
Yeah, and I think that's probably what cloud vendors in general do. I mean, a lot of them have these managed services where they do the patching, updating, and securing. And so why would that help a customer? I guess. I mean, I'm guessing that it's because they don't have to do the securing, patching, and that's one of the kind of more laborious, tedious things to manage, is all the updates and patching on your systems.
Yeah, in the case of updating and patching, Google uses our expertise to deploy a very secure Linux kernel that's hardened and kind of battle tested, and we deploy that Linux kernel into our fleet of servers and our data centers. We deploy that into Chrome OS devices, and we use that obviously around containers, even in the services that are running in the Google Cloud. So we're using a group of expertise to go line by line through the Linux kernel, to do fuzzing techniques to test it at scale, to make sure that we're catching these vulnerabilities. And a good example of something that we've caught in the Linux kernel was the Heartbleed incident, and that was caught during our hardening phase of our team.
Yeah, oh, that's incredible. And I think it's pretty unique that someone like a vendor has kind of can touch all the different points. I mean, all the way from hardware to the actual endpoints of Chromebook. I think that's pretty unique in terms of being able to secure literally end to end, the life cycle of all these components.
And that's a really good point. Protecting these devices, especially the newer Internet of Things devices, is a very big challenge for enterprise professionals, whether that's mobile devices or laptops, or cameras, or new types of sensors that are being deployed in these enterprise environments. Ransomware can affect these devices too, even though in the case of WannaCry, ransomware was very targeted towards servers and desktops. In the case of Google, we want to give you and all the listeners, some insight into kind of what's happening behind Android and Chromebook and our Internet of Things platform, to kind of give some clarity towards our security posture in these systems, and why we think it's so important to think about a defense in depth strategy.
Yeah, I think one of the really interesting aspects of IoT, I know you're going to talk about, you mentioned Internet of Things on this slide, but I think just a couple months ago, there was like this IoT botnet that affected over, 120,000 cameras. And these were cameras that were, I guess, had their default passwords left as their, as the password. And this botnet pretty much did a whole DDoS attack on several, on the DIN website. I think it's the Mirai botnet, right? So, in terms of from a customer responsibility standpoint, I think the expectation is, as a customer, there are kind of basic things that you need to do, which, including changing default passwords, or even the vendor should force you to change default passwords, which is, what I actually noticed with, when I bought the Google Nest, they don't let you leave it as the default password. They force you to, put a password in that's unique and differentiated. So I thought that's something, interesting with our new cloud IoT launch. I think that's something that we're trying to address is, how do you manage these, thousands, tens of thousands, even 100,000s of devices that you might have in your environment, and keep them updated so that they're not exposed to vulnerabilities, out there.
That's right. And a secure baseline, like you talked about, that doesn't have default passwords, and something that's been battle tested, and something that is constantly updated, is a really important part of laptops, mobile devices, and the new IoT platforms. And like you said, today it varies by manufacturer, which is a little bit scary.
Yeah.
So let's talk about what's happening inside of Chrome OS and what's happening in our IoT platforms. So in the case of Chrome OS, Chrome, when it launched, was always focused on speed and simplicity and security. And security is at the heart of our Chromebooks, which run on the Chrome OS software. And there are many security aspects of Chrome OS. Some of them that we'll highlight are, we do verified booting when the device starts up. We actually look for anomalies, and if we detect anomalies, we guide the user through downloading a new version of the operating system, and they start from where they left off. So it's very easy for them to, get back to where they're going if we detect an anomaly with the actual operating system when it boots up. We do automatic upgrades in the background, providing administrators with dashboards to see, how patched is their fleet of Chromebooks, for example. And for the users, it's just fully managed. They just need an internet connection. This works when they're in the office. This works, when they're in a hotel room traveling for work. Like the Chrome on your desktop or your laptop or mobile device, we do process sandboxing, which allows us to separate web applications from each other, and also separate the operating system so that web applications can't affect the operating system. Google Chrome also includes safe browsing API, which prevents you from navigating to a malicious website. If we know that a website is malicious, we stop you from actually going to that website. And then most importantly, like you said, we start from a good baseline, and we use TPM security chip to encrypt user data on Chromebooks as well. So in the event that you lose your your actual laptop, it's fine. You can just go get a new Chromebook, sign in, and you'll start from where you left off. And it's all encrypted using this security chip.
That's I didn't even know that. So each Chromebook has its own security chip that can encrypt with its, I guess, unique key.
Yeah, so each Chromebook is required to have a TPM module, and that's right. We store a user encryption key on the TPM module. So each user's data is encrypted separately on the device. And like you said, Internet of Things devices like cameras are vulnerable, and each manufacturer has a different standard towards this. And we're really working hard on the Google Cloud team to give developers, manufacturers, and IT administrators, better tools to actually manage their IoT devices and prevent them from hopefully future attacks. So Google Cloud IoT is a set of services that allow you to manage your inventory of devices, manage the configuration of those devices, automatically push updates to the operating system, for example, and then obviously take all the data and use our analytics tools to actually visualize it. And the components of that are what we call Google Cloud IoT Core. So IoT Core is a set of managed services. So Google is actually doing all the management of the actual infrastructure for you. It allows you to securely connect devices to Google Cloud, ingest data from them, manage inventory and the configurations of your devices, and then use our machine learning and big data applications to actually visualize the data that's coming off these devices. And then if you bundle this with Android, in the case of Android Things, you get an additional end-to-end security posture that you talked about at the beginning, where we're managing the operating system for customers. We're patching it. We're releasing patched security patches to Android Things. If you're using Google Cloud IoT Core, there's an inventory. You can manage configuration and the patching of those devices all together. So these are meant to seamlessly work together and provide manufacturers or makers in the world with a really secure baseline to start with. And the whole goal of IoT platform at Google is to allow the developer and the manufacturer to focus more on the application and leave the security and the hardening of the device to Google. So how do we combat ransomware is kind of the closing statement. And like we said, we've learned a lot from how we protect our own applications. And in this threat landscape, customers really need a trusted partner. And we believe Google is the best partner for customers to protect their devices, their workload in the cloud, their IoT devices. And we believe this is a way to kind of fix the broken paradigm where users are bogged down by the quarterly update process for their fleet of desktops and servers.
So that's great, Alan. And one of the things that I wanted to kind of touch upon is I guess in general, I mean, we mentioned a lot about end devices as well as the cloud platform, but what are cloud providers like Google doing to prevent these attacks in the future? I mean, there's certain things like, we can do snapshotting, backups. We talked about fully managed solutions, hardened Linux kernels. I mean, are there other things that cloud providers can do? Maybe you can talk a little bit about the DDoS.
Yeah, there are lots of different threats out there, depending on what type of work you're doing. One very popular threat in the world is distributed denial of service attacks against web applications. If you have, you're an e-commerce site or you're, hosting some news, you're vulnerable to attacks. In fact, there's regular attacks against websites. It's a common problem. So one advantage that a cloud provider, in the case of Google, is we can help architect web applications to protect them from distributed denial of service attacks. We have a software-defined network. We have global scale with points of presence in lots of countries around the world, and we can absorb attacks and protect. This is how we protect Google.com and Android and Chrome, and this is how we protect customers if they're running their workload on Google as well.
And this is something I learned recently. I'm not a security expert, but in terms of DDoS, it's not really about preventing DDoS. It's almost like you have to, can you handle and absorb the traffic, right? I mean, it's just impossible. I mean, the first step to preventing DDoS is figuring out how these endpoints are compromised. But once they're compromised, it's very hard to actually prevent DDoS. It's more about mitigating the attack. And I think, go ahead.
I was going to say you need a security paradigm that does both, right? You need a paradigm that is keeping devices up to date and patching and staying ahead of the curve from security. And then you need to be able to scale quickly, and you need to be able to absorb attacks if they happen inadvertently. So one of Google's strong suits is being able to absorb traffic very quickly. So if you're an e-commerce site and you go from 0 customers to 1 million customers on your website, the Google network is designed to help you do that. We don't fall over and have to scale up machines to do that. And in the case of news agencies, for example, Project Zero is a free service that we gave to news agencies where if you're a small news agency, we sit in front of their website to protect them from adversaries that are trying to take down their message.
Yeah, and this is public information, but I think, to quantify that, I think it was something like 70 terabits a second. Some of our pipes are that big, and that can absorb a lot of traffic with 70 terabits. I don't know of any DDoS attack that required that much or that was able to leverage that much bandwidth for their attack.
And like we said at the beginning, these lessons learned really come from our billion user applications. You can imagine that supporting YouTube and Google search and our business on our networks, a small DDoS attack really is nothing compared to what we're serving for our consumer applications.
Right. So we got a question. What are some of the customers asking you? You attend a lot of these executive briefings and even discussing and having discussions with developers. What are some common questions you're getting in terms of security?
There are lots of categories of things that we get asked when we meet with executive teams. The first is kind of trust. Customers want to know what our security posture is and how we're protecting their data. They want to know what the regulatory landscape is and how they're going to be compliant with the laws in their country. The second is they want to know how Google operates, right? We release a lot of research. We have a very large workforce. We're a company that people look to when it comes to security, and we do things a little bit differently. And I'll give you an example of that. We released some research a couple of years ago called Beyond Corp. And Beyond Corp is a new methodology for our workforce, for our corporate networks, where we got rid of the need for a secure perimeter that requires VPNs and firewalls. We moved to a zero trust model for our employees, which lets them work from a hotel room or the bus if they're commuting or from an office, and they get no more access by being in the office. And it allows us to deploy a zero trust environment for our workforce. And it's been very successful over the last couple of years.